Okay, welcome back. Now we are going to discuss about question 3. EB 3210, theory of electricity, the model paper question number 3. We have already discussed about question 1 and question 2. Now we are going to discuss about question 3. Let's read the question. The part A question is calculate the currents I1, I2 and I3 of figure Q3 using the cage of slows when R1 is equal to 6 kilo ohm, R2 is equal to 8 kilo ohm, R3 is equal to 4 kilo ohm, E1 is equal to 6 volt, E2 is equal to 8 volt. Now, during current calculations, use the names and directions as indicated in figure Q3. We must use according to this diagram. This is I1, 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 I3, I2. Okay. Now let's move to the. Uh, Now we have to find the I1, I2, and I3 using Kirchhoff's laws. We already know there are two laws. One is KCL, another one is KVL. Kirchhoff's current law, Kirchhoff, Kirchhoff's voltage law. That is the we already know that Kirchhoff's laws. That are the laws. Now let's move to the question. Now we draw the diagram again. Okay. Now we are going to draw the diagram again. Check it again. Okay, I normally draw. Okay, you in exam, if you want, please draw very neatly. I Okay, they have the R1. This R1, R1 is E1, E1. This minus, this is plus, plus minus this E2, E2, R1. This is R3, this is R2. Now they have mentioned that it's I1 current, I1 current. This is I3 current, I3 current. This is I2 current, I2 current. Therefore, if this I1 current, this current here also I1 current. I1 is going through this path. Therefore, I1, I1 here also I1. Okay. The I2 is going through this path. Therefore, here also I2. I2 is going from this place to this area. Okay. Now I use another color. Now A, okay, B, C, D, E, F, A, B, C, D, E, F. Now A, B, C, D, E, F. Okay. Now we are going to, uh, if you want, please draw the diagram. When I am teaching, please, if you want, please write down notes because it will be very helpful to you for exam. Okay. Not only the exam was open get exam. I think you can bring the notes also to the exam. Okay. Now, now we are going to use KCL. Okay. Applying KCL. Applying KCL. Now we are going to find the I1, I2, and I3. Okay. Applying is KCL at point F. Why we are going to find the uh, why we are going to apply the KCL at point F? Point F. Okay. Point F. Point F. Okay. Point F. Because here we all in this point we know all the currents. Here I1, I3, I2. Okay. I1, I3, I2. Here I1 is we already know the KCL, KVL, Kirchhoff's current law and Kirchhoff voltage law. According to the now the currents uh, i- are these currents in current or out current? These currents are out current. They are output current. Okay, normally we call out current output current because they are outgoing. The I1, I3, I2 are outgoing from this F node, from this F point. I1, I2, I1 is also outgoing, I2 also outgoing, I3 also outgoing. Not there are no there is no incoming current. All are outgoing current. Okay. Therefore, applying KCL at point F, what is the formula of KCL? KCL, what is the formula of KCL? KCL law, Kirchhoff's current law. This is sigma I is equal to 0. This is the formula for KCL. Sigma I is equal to 0. Here, all the currents are outgoing currents. They are minus. All are minus. If there is any input current or incoming current, that is plus. Here, that is plus current. Here all are outgoing current. They are all are minus I1. We have to add anything -1 minus I1 plus minus I2 plus we have to play, add everything. We have to sum everything. Minus I1 plus minus I2 plus minus I3 is equal to 0. Therefore, minus I1 saya I2 saya I3 is equal to 0. uh, Mostly I never skip the steps because some students may understand the quickly. Some students may need a lot of time to understand. Therefore, I teach you for every students. Therefore, I will go every step by step. If it's boring, please watch the video in double speed. Okay, double speed. Some students may need every steps. Therefore, I write all steps for all students. Okay, minus I1 minus I2 minus I3 is equal to 0. Therefore, I3 is equal to I3 is equal to minus I1 minus I2 minus I2. Okay, now we go to now we have applied the KCL at uh, point F in and we have find the relations between the currents. We know the relationship between I1 and I2 and I3. Okay, I1, I2 and I3. We know the relationship. Okay, now we are going to apply KVL. KVL, Kirchhoff's voltage law. Kirchhoff's, Kirchhoff, Kirchhoff's voltage law. Mostly you don't need to write fully like that. Okay, you if you at the exam you can mostly it's enough applying KVL. Applying KVL it's enough. Applying don't need to write fully. But if you write completely, it's no problem. But mostly it's enough. We don't need to spend a lot of time to write. Okay, applying KVL to the loop. Applying KVL to the loop. Now I am going to apply the KVL to the uh, loop ABCDFA. ABCDF ABCFA ABCFA. Okay. Now I am going to use the KVL to this loop ABCFA ABCFA. Now I am applying KVL to the loop. Applying KVL to the loop. Which loop? A B C F A A B C F A in which direction? That is this direction A B C F A. ABCFA in this direction, in right direction. Bravo. Okay. ABCFA. What is the common formula of KVL? That is sigma E. Sigma E plus sigma IR. Sigma E plus sigma IR is equal to 0. Sigma E plus sigma IR is equal to 0. This is the common formula for the KVL. Okay. This is the voltage. This is current and resistance. The sigma means summation. Summation. We already know. We don't need to discuss about deeply about that. We already discussed in advanced level. Now sigma E plus sigma IR is equal to 0. Now we are applying KVL to the loop ABCFA. Let's look at now ABCFA. We are using the applying. We are applying the KVL to the right cycle. Right side. In right cycle or right side. Okay. Everything is okay. Uh, we have please I1 into R1. We already know KCL. We don't. We already know about KCL and KVL and how to apply the equations. Now we move. Now we are going. We are using this direction. No? This direction. Okay. ABC FA. This direction. This okay. This direction. Therefore, I1 into here the current is going to my our direction. We are using this direction of direction. Our current is also going that direction. Therefore, it's I1. I1 into R1. Therefore, I1 into R1. R1. Okay, I1 into R1. Here we are going into in this direction. Now, first, first we meet minus 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 terminal. No, this plus terminal. This minus terminal. Here first, if we go to from this side, we first meet minus terminal. We first touch the minus terminal. Therefore, minus E1. Okay, minus E1, minus E1. Then we are going. We have discussed about this. We have already discussed about this. Now here we are coming from this side to this side. But I3 is in opposite side. Therefore, minus I3 into R3, minus I3 into R3 is equal to 0 because there are only three components R1, E1, R3. Therefore, is equal to 0. I1 into what is R1? R1 is equal to 60 into 10 to the power 3 ohm because R1 is equal to 6 kilo ohm. No, yeah, we don't need to write ohm. Okay, I1 into 60 into 10 to the power 3, 6000 ohm minus what is E1? E1 is equal to 6 volt minus I3. We substitute another equation instead of I3. What is I3? We already find using K, KCL, Kirchhoff's current law. I3 is equal to minus I1 minus I2. Therefore, I1 into R1 minus E1 minus I3. I3 is minus I1 minus I2. Minus I1 minus I2. I2 into R3. What is R3? 4 into 10 to the power 3. 4 into 10 to the power 3. 4000 kilo ohm. 4000 ohm. You will 0. Therefore, if you find the final answer, you will finally get 5i1 plus 2i2. 5i1 plus 2i2 is equal to 3 into 10 to the power minus 3 minus 3. Okay, using KVL to the loop ABCFA in this direction, right direction, right or left, right direction. Okay, right direction, this direction. Finally, we get the final equation that 5I1 plus 2I2 is equal to 3 into 10 to the power minus 3. I name this equation as 1. Okay, one equation. Now we are going to apply the KVL to the big loop. Now we are going to apply the KVL to the A B C D E F A. Big circuit A B C D E F. Already we discussed about A B C F A, A B A B C F A. Now we are going to apply the KVL to the A B C D E F A, the big circuit. Okay, A B C D E F A. Now applying the applying applying the KVL. Please, you must write uh, these statements in your exam. Okay, mostly you must write. Okay, applying KVL or the KVL or applying KVL to the loop. Applying KVL to the loop. Applying KVL to the loop. A B C D A B C D D E F A E F A in the same right direction. Okay, in same direction. Applying KVL to the loop ABCDFA in right direction. If you please consider here, if you in loop, if you now in KVL, if you in applying KVL in applying KVL, if you use any word here, if you start in A, you must end in A. Okay, please if you start in A, you must come to N. If you start in A, you must end at the A. Okay. Yes, okay, we already know this. Someone write only A, B, C, D, E, F. You must write till A. Okay. If we start at A, we must come to A again as an ending point. Okay. Now we are going to apply the KVL. Now, uh, here I will start from here. Okay. Uh, we now we are going to find the KVL in the same direction. No, in this direction. No, output. Yeah, I1 is in same direction. Therefore, I1 into R1. 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 First, we touch the minus terminal of the battery. Therefore, minus E1. Therefore, minus E1. Minus E1. Minus E1. Now we are going this side. Now we touch the plus terminal. Therefore, plus E2. Plus E2. Plus E2. Then E2. Now we are going in this direction. Now here I2 is in opposite direction now. Therefore, minus I2 into R2. Minus I2 into R2. If you don't understand what I am doing, please write in your notebook or anything, rough paper. Okay. Then you can. I am also already. I have write in my notebook. Okay, for my self study again. If you write with me, you can quickly you can find the flow of my method quickly. Okay. Sometimes if you only watch the video, sometimes you may face trouble to understand. Right? Okay. You please, if you write, it will be very helpful to understand. Okay, minus I2 minus I2 into R2. Okay, minus I2 into R2. Then I2 into R2. Now, okay, we have already uh, we have discussed about. Okay, discuss. Okay, that's we use this loop. No, therefore we don't consider about R3. Okay, this is the equation using our Kirchhoff's voltage law I1 R1 minus E1 plus E2 minus I2 to R2 is equal to 0. Now we substitute the values I1 into what is R1? R1 is equal to 6 into 10 to the power 6 into 10 to the power 3 minus E1 is equal to minus E1 is 6. 6 E2 is equal to 8 minus I2 into what is R2? R2 is equal to 8 kilo ohm. Therefore, 8 into 10 to the power 3 ohm, which is equal to 0. Finally, we will get, if you summarize this equation, finally you will get the final equation that 3 into I1, 3 into I1 minus 4 into I2. 3 into I1 minus 4 into I2 is equal to minus 1 into 10 to the power minus 3. Okay. 3I1 minus 4I2 is equal to minus 1 into 10 to the power minus 3. I name this equation that second equation. Okay. Now there are two equations. One equation, first equation is 5I1 plus 2I2 is equal to 3 into 10 to the power minus 3 uh, using KVL. The second equation is 3I1 minus 4I2 is equal to minus 1 into 10 to the power minus 3 is second equation. Here only there are how many unknown variables are there in every equation? Only I1 and I2. I1 and I2 here also in first equation I1 and I2 because that is the reason we find in first at first we found the relationship between I1, I2, I1 and I2, I1, I2 and I3. That is the reason we found the relationship. Therefore, we substitute I1 and we have for I3 we substitute the equation in I1 and I2. Okay, we substitute the equation in I1 and I2 instead of this I3. Therefore, we finally got the received the answer, received the equation in only I1 and I2. That's why we first found we used the KCL not at point F. Therefore, now okay. Now there are two equations and two unknown variables. Therefore, we can find I1 and I2. Okay. Okay. Now first equation is 5I1 plus 2I2. 5I1 plus 2I2 is equal to 3 into 10 to the power minus 3. This is the first equation. The second equation is uh, 3I1 minus 4I2 is equal to minus 1 into 10 to the power minus 3. Second equation. If this is very simple. You can find the final answer by the first equation and by using the first equation and second equation, you can find the I1 and I2. The I1 is equal to 5 by 13. 5 by 13 milliampere. This is the answer of I1. I1 is equal to 5 by 13 milliampere. I1 is approximately equal to 0.385 0.385 milliampere. Okay. If they are asked, if they ask the question that find the I1, if you if you give the answer like this, according to my opinion, it's very best. But if you want to calculate anything, you please you must use this number, okay, 5/13, because if you I1 is approximately equal to 0.385 milliampere, because it will be the continuous it will go continuously, no. Therefore, if you want to substitute anywhere instead of I1, please use 5/13. No, don't use this. If you use 5/13, we will get very accurate answer. Okay. Now the I1 is approximately 0.385 milliampere. I2 will be I2 is equal to I didn't. I didn't. I don't need to tell how did I derive the final answer for I1 and I2, because it's very simple. No, we can find the I1 and I2 very simply using these two equations. Therefore, I reduce the time. Uh, if anyone didn't understand, please comment on um, uh, please comment on YouTube. I will I will reply. Okay, I2 is equal to 7/13. 7/13 milliampere. Milliampere. I2 is equal to 7/13 milliampere. I2 will be approximately equal to 0.538 0.538 milliampere. Now we have found I1 and I2. Now we can find I3 easily, because I3 is equal to minus I1 minus I2 minus I1 minus I2 using KCL at point the F. We derive this equation. Therefore, I3 is equal to what is I1 minus I1 minus I1. Here substitute 5/13. 5/13. I have already told you. If you want to substitute anywhere, you must please you must use this 5/13. Not to use that decimal number. Okay, use this number 5/13. This is exactly same answer. Exactly 5/13 is exactly same. 5/13 into 10 to the power minus 3, because 5/13 into 5/13 milliampere, no, therefore minus 5/13 into 10 to the power minus 3 minus that is I2. I2 is equal to 7/13 milliampere. Therefore 7/13 milli means 10 to the power minus 3 ampere. Therefore the final answer will be I3 is equal to -12/13 milliampere. -12/13 milliampere. Therefore, I3 is approximately equal to -0.923 milliampere. This is very simple. Therefore, we have found the final answer. I1 is approximately. Finally, please write this in finally. Okay. Finally, finally, finally. Oh, therefore, finally, oh, therefore, I1 is equal to approximately. Please write the equation. I1 is approximately 0.385 milliampere. I2 is approximately equal to 0.538 milliampere. I3 is approximately equal to minus. Don't forget minus 0.923 milliampere. Please finally write the answer. What they asked in the question, they asked calculate the currents I1 and I2 and I3. No, this is the question. No, therefore finally please write that. Therefore I1 is equal to I2 is equal to I3 is equal to. Okay. Now we have discussed the part A. Now we have to discuss about part B. We can discuss the part B in next video. Okay. Bye.